So although this question is a little tedious by its inherent nature, I would like to still try and break this down, but perhaps in a brief manner. I feel like if I go too much into it, then perhaps it could overcomplicate really the simplicity of the problem, right? I don't want to take away from the simplicity of the problem. So really, I mean, it says here that we have 150 milliliters of a 0.60 molar CaCl2 solution. So let's go ahead and first be visual about it, right? So we have one particular solution. Which apparently what they're saying is it's 150. Well, actually, see, that's why you have to sort of read the question carefully. It says that 150 milliliters of a 0.60 molar CaCl2 solution was mixed with another solution with other attributes. So it seems as though there is a solution, and while the question hasn't told us the original volume of the solution, it has told us that 150 milliliters of that volume, which has particular characteristics, was taken and mixed with another solution. So really, I mean, we have this mystery volume, right? The volume is a mystery, or I guess we could call the volume ml, because since it's most likely going to be expressed as milliliters in the context of this problem. But of course, we're also told that that it is a 0.60 molar solution. And of course, it is CaCl2, it's calcium chloride. And let's see here. So it was mixed with, so we took 150 milliliters. So we took 150 milliliters of this guy and mixed it with a solution. It's mixed with a 300 milliliter solution. So that means this guy in and of itself before the mixture was 300 milliliters, so 300 milliliters. And of course, it was a 0.90 molar solution as per the question. It says it was 0.90. It had a molarity of 0.90. CaCl2. So this is also CaCl2. We're really not talking about different compounds. And it's asking us what is the new concentration of the mixture. So it's saying after you add 150 milliliters of this guy to this guy, what is the new concentration, right? So we know that before the mixture, it's 300 milliliters and it's 0.90 molar. But after, right, this is sort of after mixing, right, after mixing these guys, we're told to find the concentration, right? So this is going to be a more heftier amount than the previous, because of course we're mixing stuff, right? And so we can sort of infer by now that if we have 300 milliliters and we add to that 150 milliliters, then of course 300 plus 150 milliliters is just 450. So we have 450 milliliters of the new solution, right, which is also a CaCl2. But we don't know the concentration. We don't know M, right? We want to know the molarity of CaCl2 after doing something like this. So the approach, in my opinion, I mean, we know that molarity is equal to moles of solute over liter solution, right? This is what we know in terms of molarity and concentration. So if we could somehow take the milliliters, express them as liters, and find how many moles solute would be in this particular solution, given that we've mixed a couple things along the way, which is 150 milliliters, and of course this guy here. What would be, if I had how many moles in total, then I could put mole solute over liters, which I already have if I express milliliters as liters, and then I would get the molarity. So really the intermediate question is then how many moles are there in the original solution? How many moles are there in the solution that 150 milliliters of that was taken from? Well, okay, so really what I'm trying to say here is, if I'm making it sound complicated, is, you know, one step is how many moles in both solutions, right? Well, what you could do is you could just find how many moles are in this solution. So in sample one, you have sample one here. How many moles in sample one, right? And once we have that, we can then ask ourselves another question. How many moles in 150 milliliters of sample one? Because we don't completely mix sample one with sample two, right? We only mix 150 of it. So you know, so the amount of moles that are in sample two added to the amount of moles that are in 150 milliliters of this solution is eventually going to be the amount of moles that are in the mixture combined, of course, and that we can then put as a quantity, we can put in the molarity formula, and of course get the molarity of the entire compound, or the entire solution really as a whole. So our first question is how many moles are in sample one, and then our second question is how many moles are there in 150 milliliters of sample one. And then, of course, how many moles are in sample two? And then, of course, we'll add that to the amount of moles that were in 150. And then, of course, we'll plug into the formula. So let's go ahead and do the first step here. So the first step is how many moles are in sample one. Well, how many moles are in sample one? So the idea is that if we did this in a manner that resembles stoichiometry, if we had the amount of if we had the volume of sample one, then we could start with the volume, use the molarity to get to the amount of moles that are in sample one. But we don't have the volume. So this then begins to pose another intermediate question, which is how to get the volume of sample one. That would eventually lead us to the amount of moles in sample one. So the volume, in this case, we can sort of infer by sample two. We could say that M1V1 equals M2V2. And then, of course, we know that M1 in this case is the molarity of sample one, which is 0.60. And the volume, which is of sample one, we don't know. So we're going to leave that as V1. And of course, we recognize that both M2 and V2 are given. So M2 is 0.90 and V2 is 300 milliliters, right? So this is why we set this up in a way, because we know that the information about sample two is already provided. That could lead us back to sample one in terms of its volume, or even its molarity. If we didn't have its molarity and we had its volume, we could have went that way as well. So volume of sample one is 0.90 multiplied by 300 over 0.60. So if you were to plug that into a calculator, you would get 0.90 multiplied by 300, and then of course dividing by 0.60, you would get 450. So volume one is actually 400. Let's see here, 450 milliliters, since we went into this in respect to milliliters. So now that we have the volume, right, why don't we just go ahead and update this? Let's see. So we have 450 milliliters. Perfect. So if we were to then take 150 milliliters, right, of the solution, this is sort of a conversion factor, right? I mean, we have 150 milliliters of the solution, and we want to go to, let's see, we want to find out how many moles there are, 150. So we'll convert this first to liters, although it really doesn't matter, but that's sort of the conventional way to go about there in order to use your molarity. So for every 1 liter, you have 0.60 moles of CaCl2. And of course, if you were to then plug this into your calculator, you would do 150 multiplied by 0.60, and then of course you would, let's see, 150 times 0.660, and then of course you divide by 1,000, and you get 0.09. Right, 0.09 moles. So we really didn't have to figure out how many moles were in sample 1. We went straight to how many moles are in 150 milliliters of sample 1, because we were able to situate a conversion factor here that was convenient for us. So we know that if we take 150 milliliters of sample 1 and we mix it with sample 2, we're essentially just adding 0.09 moles of calcium chloride. And of course, we don't know how many moles are there in sample 2, so we can't really add those amounts together to get the amount in the final solution. But we know that there are 0.09 moles in sample 1, so let's go ahead and find out how many moles there are in sample 2. So essentially at this point, you're given enough information to situate a conversion factor. We're given both the volume and the molarity. Beforehand, we didn't have the volume, so that's something we actually had to solve for. But we're given both of them, so this should be easy. You have 300 milliliters of the solution, and we'll multiply we'll first switch this to liters, and we'll then say that for every 1 liter, you have 0.90 moles. And then, of course, plugging this into a calculator, you'll get 0.9. Let's see. So you'll plug this in 300 times 0.90, and then, of course, you'd divide by 1,000, and you'd get 0.27. So our moles of solute in the final solution are going to be 0.09, which is of course the amount of moles that were in the first solution, added to 0.27, which are the amount of moles in the second solution. And that would be your mole solute. And of course, if you were to plug this into a calculator, you would get 0.27. So 0.09 plus 0.27, you'd get 0.36, so 0.36 moles of solute, which in case was CaCl2. So if we take the amount of moles that we have, and then of course divide, this is of course just done with, and we divide by the amount of liters that we have in the final solution, which is 450 milliliters, so 450 multiplied by 10 to the power minus 3. If we do this, we'll have 0.36 divided by 450 times 10 to the negative 3rd power, and we would get 0.8, which is our final molarity.